So folks, in this question we're given a scalar or a vector field and a scalar valued function, both of which have a domain of R3. And we're asked which of the following expressions are meaningful. So before we get started, let's go ahead and just flesh out what maybe the vector field f might look like. So remember, it would take in components x, y, and z, because this is coming from R3, and it would output some vector where each one of these vectors is a scalar valued function. I probably shouldn't use f since we use it elsewhere, so let's do JKHL, let's do, running out of letters, P of x, y, z, Q of x, y, z, and R of x, y, z. I think we'll be okay with that. Oops, and that's a vector. And then we've got a vector valued function where we could think of f of x, y, z as just being some, it inputs three values and outputs some expression. Maybe we call it w or something like that. So now we can look at each one of these expressions and see whether or not they're meaningful. So as a reminder, when we talk about the curl of an object, probably a nicer way to write the curl to remind ourselves what it means is that it's the nabla operator crossed with whatever that object is. And so right here we see that you can only take the curl of a vector. That is, what you need are three component functions. So you could look at taking, for example, nabla cross f. That would be well defined, and that would be something like partial x, comma partial y, comma partial z, and we're going to cross that operator vector, that nabla operator vector, with the component functions p, q, and r, and that makes sense. But in the case where f is just a scalar valued function, this does not make sense, so this is meaningless. Okay. The next one that we're asked to look at is the divergence of the gradient of f. So let's see whether or not this one makes sense. So as a reminder, another way to think about the divergence was in that other notation we gave, or we could think about it as the del operator crossed with whatever we're taking. So we'll put del cross the object. So, or excuse me, dot the object. So if we're going to be taking the dot product of two things, we need to think of them as both being vectors. So this object needs to be a vector. But the question is what is nabla f? Well, that's just the gradient, which is itself can be thought of as a vector field. That is, it is partial f, partial, in this case, let's see here, we wrote x, y, z, so we could write partial f, partial x, comma, partial f, partial y, comma, partial f, partial z. And so this is itself a vector, and so it makes sense to talk about taking the divergence of that. So this is this makes sense. Check, that works. Let's look at the expression gradient of f crossed with the divergence of f. Well, what is the result of having taken the divergence? We said just a moment ago in this video that the divergence is the del operator dotted with some object. When you take the del operator and dot it with an object, you end up with a real number, the dot product, in a sense, or in this case, I guess a real valued expression. But that means that this is not a vector. So I guess we could say it's a number or an expression, depending whether you're doing it point-wise or not. But the big thing is that it's not a vector. So this is not a vector. So it doesn't make any sense to be doing a cross product with. So this one is meaningless. Okay. So the last one here, we've got the curl of f. Well, we said just a moment ago that when you take the curl of an object, in this case the vector field f, you're going to take the gradient operator, that nabla operator, and you're going to cross it with another object, which has to be a vector field. So that tracks, right? That makes sense. And it's going to return a cross product, which is itself a new vector. And so then it makes sense to take the curl of that again. So this is a meaningful expression. We're taking the curl of f, that is, we're taking the curl of a vector field, which gives us another vector field, or another vector if you're doing it pointwise, and you can take the curl of that again. So that does make sense. These two operations are meaningful, where the first and third are not. Hope this was helpful.